Okay, 8.6, day 3. Today, we're still solving, but now they're going to be inequalities. That didn't help, did it?
No.
It's easy to see.
Yeah.
Is it? It's just my angle that's bad? Got it. Your angle as well?
Put over one.
I swear, I have paper to cover it. Just haven't gotten there yet. Okay, but anyway. So we're solving rational inequalities. Now, solving rational inequalities is going to have a lot of similarity to solving rational equations. That shouldn't probably be shocking because solving a linear equation is a lot like solving a linear inequality. There are slight differences though. If I have something like negative 2x is greater than 4, you would tell me to do what to get x alone? Divide by negative 2. The difference in solving an inequality versus solving an equation is now that I've divided by negative 2, what's going to happen? The inequality is going to flip. After we have that, we do generally then graph inequalities on a graph. We give a visual representation of this. You do know that if I write it on the active board, it's not something you have to write down, right? I'll take that as a no. Okay, and then we graph it. We put an open circle if it's not or equal to. We put a closed-in circle if it is or equal to. And then we do some sort of indication of where it goes. I tend to shade the graph. So that's a graph of the equation, or the inequality, I should say. Now, graph it, as I stated, solving rational inequalities is a lot like solving a rational equation. The only problem is when we go through this process, we're going to have an issue with rational equation solving. And that is, when we go through and we solve a rational equation, we find the least common denominator, we multiply it by all the things, the problem ends up right there. If you multiply by something that has a variable in it, do you know if it's positive or negative? No. Which causes this situation where we wouldn't know what that inequality is, which means we don't know where the solution goes. We just know that it's got an endpoint right here. We don't know if it's less than, we don't know if it's greater than in the case for rationals. This one, of course, we do know it's not rational. But that becomes an issue in rational equations. And so the way that we get around that is we build our answers around that graph and use that graph to help us. So as we go through it and solve these today, we are going to take and we are going to work with a number line, and we're going to break a number line. I know. We're going to break a number line into what I refer to as possible regions. Much like that one that I just had on the board, when I had that solution there in the middle, it had two regions there. It could have been the side left of it or the side right of it, the less than or the greater than, that would work. Now, in a rational inequality, though, those regions are not just broken up by solutions. That is one place that breaks them up. I feel like I'm missing a word in this. But we break a number line into possible regions. Those regions are broken up by the solutions, but there's also another thing that happens with the graph of a rational equation. If we think about a rational equation, we always had to work with those asymptotes, those places where the graph jumped over. We have that happen in these number line graphs as well. So the excluded values also end up breaking up these number lines. So we're going to have inequalities like 1 over 3k plus 2 over 9k is less than 2/3. We want to build that number line. So in order to build that number line, the first thing we are going to do is we are going to find the excluded values. Now, excluded values, it's been a bit since we talked about them in depth. How do we find them again?
Taking a number, setting it equal to 0.
I heard not just any number equal to 0, and I heard some other mumblings. Denominator. Set the denominator equal to 0. Equals 0. Equals 0. Equals 0. And I solve each of them. The first one I divide by 3, k is 0. The second one I divide by 9. That one also gives me k is 0. The third one doesn't make sense. 3 equal to 0 is not logical. Constants equal to 0 will give me nothing. You don't actually have to set them equal to 0. I just make a point when I do it. So, I have a single excluded value. K is 0. It's the same on both of those. Now, I'm going to need to hold on to this excluded value. So, I typically do something to draw my attention back to it so that I don't lose it later. For me, I tend to draw a star next to it because I can easily find stars. For some people, it's they highlight it. For some people, it's they do kind of a squiggly underline. Some people just write it obnoxiously large. As long as you remember to go back and look for that, you do what works for you. So, find the excluded values. The other things that we have to do is find the solutions to the equation. Note I said equation. That's not an equation. That's an inequality. So, I then take it and I change it to an equation. I change my less than symbol into an equal sign. Now, I often see that there are people who just go back and say, okay, equal. Which is perfectly fine. It's not going to be that big of a deal if you can tell what that inequality is later. A lot of people, once they've written the less than sign, the moment they write the equal to sign on it, they struggle to see what it was originally. We're going to need that inequality later. That's why I always write it as a separate equation. Okay, I want to solve this. In order to solve a rational equation, first thing I find is the least common denominator. In these denominators, none of them have addition or subtraction, so none of them are going to be factored. I'm just focusing in on the monomials. So I'm going to treat them like regular fractions, focusing on numbers first, variables second. Numbers, I've got a 3, a 9, and a 3. Smallest thing 3, 9, and 3 can all become, or the smallest thing they all go into, in other words. 9. Okay, I've got a K, and no Ks. K to the first power. Variables, you take them to their highest exponent. Highest exponent here is just 1, so least common denominator is 9K. I then multiply that least common denominator by each of the fractions. Not the top and bottom, just the top. By doing this, what happens? Stuff cancels out of numerator and denominator. Most specifically, the denominators go completely away. The 3K and the 9K simplify to leave a 3. The 9K and the 9K simplify to nothing. The 3 and the 9K simplify to 3K. So I'm left with the 1 times the 3 plus the 2 times the nothing equals the 2 times the 3K. That's 3. That's 6K. 5 equals 6K. K is 5/6. That's another important value that I'm going to need. Once I have those, I'm going to actually create the number line. I'm going to create it with breaks, or holes essentially, at each of the excluded values and each of the solutions. Now when it comes to my number line, a couple things you gotta know. First off, I am not picky about this number line having a specific scale. In fact, I don't put a scale on it at all. When I go and make my number line for the sake of these problems, I got my line. I recognized how many different places my graph is going to be broken up. One solution, one excluded value. They're not the same number. Sometimes they can be the same number. That would mean that technically that number would not be a solution to the equation. Doesn't make a difference on these ones. You make a break in the graph at however many of these unique numbers there are. There are 2 unique numbers. So, I make 2 little dashes on my line. Now, those, if my inequalities were ever or equal to, they could be closed circles. Those are a lot harder to work with because you also have to check other things about them. Our book doesn't do that. Our book does not torture you that way. Our book always makes them greater than symbols or less than symbols, and that's it. Which means these are always just going to be open circles. And I label them with their corresponding numerical value. Making sure that when I label them, number lines, the left side is smaller, the right side is bigger. Put them in order, left to right, smallest to biggest. Between 0 and 5/6, k equals 0 is smaller, k equals 5/6 is larger. So I put the 0 on the left side, the 5/6 on the right side. Now on this number line, it is possible that this region works, or that this region works, or that this region works, or some combination of any of them. Or possible that none of them work. That's rare, but it's possible. To figure out which regions work, I run a test. Specifically, we test each region. What do I mean by test each region? I mean, what? Yeah. I plug one number from each region into the inequality. Because if one number in that region works, every number in that region works. If one number in that region doesn't work, every number in that region doesn't work. In this case, I have 3 regions. Sometimes I'll have 5, 6, 7, 8. Okay, I'm probably not going to get to 8, but I could have a lot of regions, or I could have very few regions. So just keep an eye on that. This case, I have 3. I pick a number from each region. This first one, I need a number in this region. This region is the region smaller than 0. -1, -2, -4,583. I don't care. Pick one. I like -1. So I'm going to test k equals -1. If you want to test -2, you can. It's fine. I go to my original inequality. I plug when k is I plug k equals -1 into it. 1 over 3, -1, plus 2 over 9, -1, is less than 2/3. Now from here you've got a couple of options. You can go through the math. You can plug it into a calculator. Be careful of that. We're going to chat about that. Or you can use a little bit of logic. Sometimes a little bit of logic is all you need. Would you agree with me that this first fraction is negative?
Yes.
Yes.
Would you agree that this one's negative?
Yes.
Would you agree when you add negatives you get a bigger negative?
Yes.
Is a negative smaller than a positive?
Yes.
This one works. By the way, those of you who struggle with greater than and less than symbols look like capital L's that got squished. There is the alligator as well. Alligator eats the bigger number. Why did I write test? I was trying to write true. Now, that being said, do you have to go through and do it the way we just did it? No. Can you type it into a calculator? Absolutely, but you have to be careful. If I go to my calculator and just type this in as written, if I go to plug the left side into my calculator like this, this is not the same thing as this. Plugging it into the calculator like this, I plugged in this equation. I do teach this more than once a day. So, not quite the same thing. Now, with a -1, is it going to make a difference? No. With any other number, will it make a difference?
Yes.
Absolutely. When you go to type this into a calculator, you need to do one of two things. You either need to make sure that any side of the fraction that's not fully simplified is in parentheses, or you simplify that side of the fraction. Is it so hard to do 3 times -1? No, you could probably just do that and type 1 divided by -3 plus 2 divided by -9. It'd work out. Okay, anyway. We plugged -1 in. That is a true statement. Therefore, the region I just tested works. So, I shaded in. Shaded regions on a graph like this are regions that work. So I shade it in and I move on and I check the other regions. This is the next region. Any number in between 0 and 5/6 works. 0.5 works. I wouldn't do 0.5 or 1/2. They're the same thing. I would do 1/3. Do I have to do 1/3? No. Is there a reason why I do 1/3? Absolutely. And you'll see it once I plug it back in here real quick. 1/3 times 1/3 plus 2/9 times 1/3 is less than 2/3, or at least that's what we're checking. Isn't that a nice, easy multiply? 3 times 1/3, 1. 9 times 1/3, isn't that a nice, easy multiply?
Yeah.
That's why I chose 1/3. Plugging in 1/2 will work just as well. I like this because I recognize that turns to 1, and 1 divided by 1 is 1. That turns to 3, so that's 2/3. 1 plus 2/3, is that smaller than 2/3? No. This is false. So, this region where I have my 1/3 doesn't work. So what I tend to do is I tend to draw like a little X above it just to indicate I checked it, it didn't work. You don't have to put anything there. Just, you could put a smiley face, a frown, or not, don't put a smiley face. Not a smiley. Frowny face. Some people do smiley faces and frowny faces for this area works, smiley. This area doesn't work, frown. I've seen people do it all different ways. You just need to know which regions work and which regions don't. Okay, one more region. This region is for values where k is bigger than 5/6. I like 1. 1 over 3 times 1 plus 2 over 9 times 1 is less than 2/3. 1/3 plus 2/9 is 5/9. 5/9 is 0.555555555. 2/3 is 0.6666666. Which one is point? Lots of 5s. Smaller than point? Lots of 6s?
Yes.
Yes, this one's true. Again, could I have done all of that in my calculator? Absolutely. Will I a lot of the times? Okay, so I shaved that region in, and I'm almost done with this problem. The last thing you have to do is just actually tell me the answer. The graph is not the solution. The graph is a visual representation of the solution. It is in itself not the solution. So the last thing you have to do is write that solution. My solution is all of the shaded regions. This shaded region is for the k values that are smaller than 0. You can find answers there, or you can find answers over here. This is for the k values to the right is greater than, not 1, 5, 6. Now speaking of that, one of the most common errors I do see on these problems is that people use the test points as the numbers in their solution. Those are not what goes here. The numbers that go in your solutions are the things that were the solutions to the equations or the excluded values, not the test points. That's our final answer. Okay, got one more example for you. These ones might take up a little bit of room. Interesting sound effects.
Is 2 the only excluded value? Or is 0 also excluded value? No, it's just using-
Devin, what's the first thing I do on these problems?
That was. Did you pull my card? Or you just. Okay, I'll let her in. First thing.
Look at the number 1 then.
Yep. I don't know, I didn't organize your notes.
Okay. Find the extreme value.
Find the excluded value.
Oh. Only.
You're getting algebra mixed up.
You're fine.
Did anybody talk to you over there? Like, holy shit.
Okay, it's enough. Let's get back to this. Tim, how do I find the excluded values?
Set them equal to 0.
Set what equal to 0?
The denominators.
You got it. 3 equals 0, k minus 2 equals 0, 4 equals 0. Is 3 ever equal to 0? Is 4 ever equal to 0? X minus 2 equals 0, x is equal to 2. Does that answer your question, Landon?
Sure.
Mason, what do we do next?
Solve the equation.
Solve the equation. So I need it as an equation, so I rewrite it with an equal sign. Sienna, in order to solve that, what do I have to find?
Your LCD.
Least common denominator. Okay, so pluses or minuses get factored. X minus 2 doesn't factor. My monomials are 3 and 4. 3 and 4, smallest thing they go into?
12.
12. And I also need the x minus 2. Nicole, what do I do with that LCD? Multiply it by each of the numerators. Then I start to simplify. First one, 3 and 12 leaves me with 4. X minus 2's are dead. 4 and 12 leaves me with 3. Ian, what's my equation look like now?
B?
Yep.
Oh. You're quiet. So, alright, so I want to say 4x. And then the x minus 2.
In parentheses, of course.
Then minus 12. And equals. And then 3x plus 1 and then x minus 2 parentheses.
As in both of them go in parentheses or only one of them?
Both.
Both.
Thanks, Kevin.
Oh, yeah, I don't know.
Thanks, Devin.
Who said that?
Okay, so remember binomials, when you are solving, you do want them in parentheses. Okay, we're going to distribute out. This side's pretty easy to distribute. 4x times x is 4x squared. 4x times negative 2 is negative 8x. Then we've got this minus 12. On this side, I'm having to distribute multiple times. You want to distribute the 3 first or the x plus 1 and the x plus 2 first? I heard the 3 first. Okay. I get 3x plus 3. Now, when you are having to distribute multiple times, you put those parentheses right back on there because you have to distribute again. 3x squared minus 6x plus 3x minus 6. This is a quadratic equation. Sometimes the quadratic equations, the quadratic piece of it cancels out and you're left with a linear equation. It's not doing that here. Quadratic equations, in order to solve them, you need them equal to 0. So those two together is a negative 3x, by the way. And I want my x squareds to be positive, so I'm moving everything to the left. So minus 3x squared plus 3x plus 6. I get x squared minus 5x minus 6 equals 0. Leah, how do I solve this?
I don't remember what it's called.
Starts with an F.
Factoring.
Factoring. Could do quadratic formula, it's easier to factor because this is a nice shortcut factoring. Two things that multiply to negative 6 that add to negative 5. Negative 6, positive 1. And in the shortcut, you go directly to the parentheses. And we set them individually equal to 0. X is 6. X is negative 1. Remembering that those are values that I'm going to use, so I tend to star them. Because Maggie, what do I do at this point? Make a line graph. Okay. How many breaking points do I have on this graph? 3. I don't care about the spacing of them. Again, I don't generally put a scale on this. I do it just to kind of get my regions. 3 breaking points, they're all going to have open circles. I make sure I label them correctly. The one on the far left is -1, the one on the middle. It's 2, the one on the right. I chose that order because I need to go from smallest to biggest.
You have to put the x equals.
You do not have to put the x equals. I put the x equals there to differentiate it between the test points. Speaking of which, next step is to test. Addie, Welch, what number should I test over here?
-2.
Sure. So I plug it into my original inequality. -2 over 3 minus 1 over -2 minus 2 is less than -2 plus 1 over 4. This one's a little more complex than the last one, so I'd probably grab out my calculator. -2 divided by 3 minus 1 divided by, either I need parentheses or I need to actually do the subtraction. -2 minus 2, -4. That's the left side. The right side, -2 plus 1, -1, fourth. I have a less than symbol right here. Is this less than this?
Yes. Yes. It's negative.
When they're negative, a bigger digit is a smaller number. So yes, that is less than. That is true. Hi, Shade. CJ, Shipley.
1.
What do you want me to test here?
1.
Oh, you were answering my question. Okay. If you want to do 1, you can. Personally, probably would have done 0. People tend to forget 0. That's why I mentioned it. Okay, so now 1/3 minus 1 over -1 and 2 over 4. Is that smaller than that? No. False.
How would you do 0 over 0? Is that just 0?
0 over anything's just 0. That's false. I tested 1. I'm going to make a little X just to indicate I did the test. Okay. Next one I'm going to test. Something in that region. Caitlin. What number would you like me to test in this region? 3. Sure. Three over 3 minus 1 over 3 minus 2 is less than 3 plus 1 over 4. I like 3. Because this becomes 1. And this becomes 1. And 1 minus 1, 0. And that side's 1. Is 0 less than 1?
Yeah.
Yes. True. That region works. One more test to do, because this one has 4 regions. Rachel, what number would you like me to test over here? 8, sure. Eight over 3 minus 1 over 8 minus 3 is less than 8 plus 1 over 4. 8 divided by 3 minus 1 over 5.
That's it.
9 over 4. What?
Is this supposed to be 8 minus 2? Or 1 over...
2, yes. Good eye. The equation has x minus 2. I don't know why I put 3 in. Let's try that again. So that's 1/6. And then that one's 9/4. 2.5 less than 2.25? Nope. Okay, I tested all my regions. Now it's about getting my solution. Now, when writing the solution, sometimes it's a little bit easier than others. This piece should be fairly easy. That is x's that are, to the left is less than, and the number that they're less than? -1. Make sure you're doing it at the breaking points. Or, these ones tend to be a little bit harder to do. Are they challenging? No. Do they require a little more thinking sometimes? Yes. When you've got one of the ones that's in between two values, the way that you do it, the way you write these inequalities, you start with the smaller of the two numbers, 2, and you say that that is less than x, which is less than the bigger of the two numbers, 6. That's our solution. So, process. Tedious?
Yeah.
Yes. Are each individual step really all that challenging?
No.
Maybe the solving a little bit for sometimes, but for the most part, it's not that terrible. It's just a tedious process. Book assignment today. I know, we haven't had many book assignments this trimester.
This is 8.6.
Yes. I like the page number on the top of the homework assignment. That's how I grade it. I don't grade it by the section.